Hello everyone. So in this video we are gonna learn about how to find the radius and interval of convergence of the series. So here is the series given, that is x plus 2 to the power n divided by n into 4 to the power n. So to find the radius and interval of convergence of such type of series, we will use the ratio test. So I have mentioned the ratio test here. Like limit n tending to infinity a n plus 1 divided by a n less than 1 mod x less than a, then minus a to a. So here we can see the series given is we will write the series as a1, that is a n. So a n is x plus 2 to the power n divided by n into 4 to the power n. So to write the n plus 1th term, we will replace the n by n plus 1. So x plus 2 to the power n plus 1 divided by n plus 1 into 4 to the power n plus 1. So if we will divide these term, that is a n plus 1th term by a n, then we can easily see from it here that x plus 2 to the power n plus 1 divided by this is n plus 1 and this is 4 to the power n plus 1. So if we will divide this term, this denominator will come in numerator, n into 4 to the power n, that is x plus 2 to the power n. So if we will just cancel out the powers, so here it will become x plus 2 divided by 4 and it will become n divided by n plus 1. So this term. So we have to put the limit n tending to infinity in this term, n tending to infinity mod of the similar term, we will write it here, that is x plus 2, this is n, and if we will take out n common from this will become 1 plus 1 divided by n. So it will be less than 1. So this n will cancel out this n, and this 1 by n will tend to 0 because 1 by infinity will be 0. So the whole term will become x divided by 4, x plus 2 divided by 4 mod less than 1. So to solve this inequality, we can write minus 1 less than x plus 2 divided by 4 less than 1, and if we will cross multiply 4, so what it will become? It will become minus 4 less than, this will become x plus 2 and this will become 4. So to solve this, we will subtract 2 from both sides. This will become minus 6 and 2. So x belongs to minus 6 comma 2 open interval. So now we have to check the interval whether series converges or diverges at the end points. So at left end point, we know that we will put x is equal to minus 6 because left term of the interval is minus 6. So if we will put x is equal to minus c in the series, that is n is equal to 0 to infinite. So it will become? It will become minus 4 to the power n divided by n into 4 to the power n. So after solving this, what it will become? N is equal to 0 to infinite. So it will become minus 1 to the power n divided by n. Then now we can say that this is an alternating series and 1 upon n is less than 1 upon n plus 1. So this is the alternating series which is decreasing in nature. So this series will converges by AST, means alternating series test. This series converges by alternating series test. Now to check the right endpoint, at right endpoint, at x is equal to 2. So 2 plus 2 will become 4, 4 to the power n will be cancelled by 4 to the power n. So this series will become n is equal to 0 to infinite, and this will become 1 divided by n. So 1 divided by n, here n to the power is 1. So by P series test, since value of P is equal to 1, then this series is divergent in nature. So from the above two results, we can easily say that the interval of convergence will be, so there will be an equal sign at -6, because at -6 the series is convergent, but at 2 series is not convergent. So this is the interval. We can also write this as x belongs to -6 to 2, and at 6 we will use the closed bracket and 2 will be used open bracket, because 2 does not include the interval of convergence. Now to find the radius of convergence, we will subtract the upper limit minus lower limit and we will divide it by 2. So this whole term will become 4. So ROC will become 4. ROC here means radius of convergence and IOC means interval of convergence. So this is IOC. So these both are the answers and we can match it from the options that is given. So to learn these type of concepts, you can ask further more questions by writing them in comment section below or visiting our website. Thank you very much.